All right, so for our very last topic of Algebra 2, we're going to try and solve some of these word problems. Just read the first one.
What the?
Read it. It's a fairly simple sounding problem, right? So let's read just number 1 together. Kim can install a new deck in 12 hours. Eugene can install the same deck in 10 hours. Find how long it would take them if they worked together.
What the?
Try and solve it without me telling you how to do it. Just see if you can come up with something that makes sense, something reasonable. Number 1. I'll figure out the actual answer and we'll see if anybody has gotten it. If you get an answer, you can tell me, and I'll tell you if you're right. Adam, you got an answer?
Just in my head, is it 5.5 hours?
How'd you get that number?
Okay, well, so I was just like thinking about it, kind of like, so I feel like two people can work at like a 12-hour pace, right? They're both gonna kind of split the work, right? So wouldn't it take them like 6 hours, like, do it together maybe?
If they were working at equal speeds.
Yeah. equal speeds. Now, and then like, I kind of just like, split up 12 and 10, 11 and 5 hours.
Oh, I see. So, not quite. I like your theory, though. I think by chance, the real answer is very close to the one that you just gave. Does everybody get an exact answer? Or have a thought on how to arrive there? Okay, well, let me tell you. The correct answer is 5 hours, and it's 5.45 repeating. So you were very, very close. Yes, though I think we'll do other examples where that you'll, yeah. So let's talk about how these work. And once you understand how these work, it's really not that bad. Okay, I promise. But it seems like an easy enough question, right? Like, yeah, I should be able to solve this, but I don't know how. You do once you think about it this way. They want to complete one complete job, right? Together, they want to complete one whole job. So think about Kim. We'll start with Kim. Kim, if they're going to complete this one whole job, it takes them 12 hours to do it. So how much of it can they complete in just 1 hour? 1/12. They're doing 1/12 of the whole job every hour, right? Does that make sense? So I'm going to have Kim. So here, just in words, I'm going to have Kim plus Eugene. Together, they're going to complete one whole job, right? The time that Kim is going to spend, they can do 1/12 of the whole job every hour. I don't know how many hours they're going to work for, so that's what I'm going to call X. So I'll just have X be the number of hours. So Kim is going to do 1/12 of the job for however many hours they have to work, right? So every hour that goes by, they have completed 1/12 of the whole job. And then I just do the same exact thing for Eugene. What fraction is Eugene completing every hour? 1/10. So I'm going to add to that 1/10. And Eugene is going to start at the right. It says it doesn't say anything like, Kim started and then Eugene started 2 hours later. They're starting at the same time. They're going to work both together until the job is done. So they're both going to work for the same exact amount of time. It's just that Kim is going to do 1/12 of the job every hour. Eugene will do 1/10 of the job every hour. And together they're going to complete one whole job. And basically all of these questions work the same way. They all work like this. I'm going to take the fraction this person completes, the fraction this person completes, and I want it to equal one whole job at the end. Does that make sense? Okay, now it is kind of like a problem. It's a little bit easier if I just write it as x over 12 plus x over 10. But it's the same idea. Now, this is a question I could have asked you yesterday. Right now, it's just solving this rational equation. So once you get past the word problem part, now, just like yesterday, I wanted common denominators. In fact, since all of my denominators are just numbers, I can just clear the fractions completely, right? So what could I multiply the whole thing by to just get rid of these fractions altogether? You guys remember how to clear fractions? I guess it's good we're reviewing it, right? Look at my denominators, 12 and 10. Give me a number that 12 and 10 both divide into. 60 works. You can do 120. You're just going to have a little bit bigger numbers, but let's do 60. If I multiply everybody by 60, remember you divide down, multiply up. So 60 divided by 12 is 5 times the numerator. That's going to be 5x. 60 divided by 10 is 6x. And don't forget, I got to multiply this one by 60 also. And now, oh my gosh, I can solve this equation all day long. That's just 11x equals 60. Divide by 11. So what do we get? 60 divided by 11 is that 5.45 repeating. So if these two individuals work together to complete this one deck job, that's how long it'll take them. And that's something. Let's try the second one. It's the same idea. It's just a different scenario. Okay, now we're picking apples. All right, cool. So Jennifer's going to pick 40 bushels of apples in 10 hours. Oh, actually, this one's a little bit different. Hold on. I don't want to do that one yet. Jump to number 3. We'll go back to 2 later. It takes Willie 11 hours to mop a warehouse. 11 hours? Maybe it's a big warehouse.
No, that's what we do.
That is, I mean,
11 hours.
I mean, let's assume it's gigantic. That's more than a whole day's work.
It's longer than school.
Anyway, luckily they're going to work together. So we have Willie taking 11 hours, my gosh. And God, I think Anjali, is that how you would say that? Anjali? Anjali can mop the same warehouse in 8 hours. How long would it take them if they work together? So thank goodness they are not working alone, because whether it's 11 hours or 8 hours, that's too long to be mopping for. But work together. Let's see how long it's going to take them. Everybody give number 3 a try. Okay, did you get an answer? You did? All right, let's try it. So, how long would it take them if they work together? Again, that's what I'm going to use as my variable. What are we in hours? X is going to be number of hours again. So I'm going to take the time that Willie spends. Willie can do 1/11 of the job every hour, right? Right, do you agree? So I'll have 1/11 times X, or just X over 11. So that is the amount of time, or the amount that Willie will complete himself. Now I have Anjali, who is going to do, say, she can do, I'm not even sure. There we go. They're doing 1/8 of the job for the same amount of time, and they're going to complete one whole job together. All right, perfect. So same idea. I want to clear the fractions here. What can I multiply by to get rid of them? 88. So that should get me 8x plus 11x equals 88, which means I have 19x equals 88, and I can solve. So 88 divided by 19 just so happens to be 4.63, blah, blah, blah. So if we round, I'll go 2 decimal places, 4.63 hours. It's always nice to stop and ask yourself, are these answers reasonable? Before we even started, I knew my answer had to be less than 8, right? Because Anjali can do the whole job by themselves in 8 hours. So if they have a helper, I know that it's going to take less than 8 hours. So this seems reasonable. Okay. Are we comfortable with this style? Because now I'm going to change it a little bit. Or should we do one more? One more, okay, one more like this. How about, let's do 7. Ah, that's my niece's name. Did you all solve number 7? All right, let's try it. So we have, I'm gonna go with Kaylee. Kaylee takes her 8 minutes to sweep a porch. Emily can sweep the same porch in 15 minutes. So Kaylee is going to do 1/8 of the job. Emily is going to do 1/15 of the job, and together they're going to do the whole job. This time you just got to be careful because we are in minutes here. So X should equal number of minutes, not hours. Because everything is in terms of minutes in this problem. Be on the lookout for that, because what if they had said, oh, this person can do something in 50 minutes, but it takes this person an hour. You got to be careful because those are different units. So you would have to make sure if one is 50, make sure that the hour is 60, not 1, because then it would be 1 minute. Right? So always be mindful, especially when they're talking time, that you're in the same units. Anyway, here we are. What number can I use to clear these fractions? 120? Really? There's not a smaller one? I believe you, but oh, feels like there should be, but I guess not. All right, so 120 divided by 8, what even is that? 15. So I get 15x there. Oh, so this must be 8. Oh, duh. Oh, gosh. So we get there. Let's add that together. What is that? 23. So 120 over 23. Did you get 5.2? 5.22, I guess, if I round to the nearest hundredth, and that's minutes. Okay, which makes sense. I knew it had to be less than 8 minutes because one person by themselves only took 8 minutes, so there's a reasonable answer. Okay, so now we're going to change the style of question just a little bit. Let me find one. I think they're on the back here. Yeah, take a look at something like number 9. See if you can, I'm gonna give you a minute to try and see if you can work that one out on your own. It's the same idea, just a little different. I'll hear your answers if you got any. Anybody think they got an answer? No? No, really? Okay, well, let's remember what we were doing on the other side, right? I was taking the time Mary, so let's put this out in words. I was doing the fraction Mary could do. The fraction Mary does times however long it takes them. And then I would add to that the fraction, we have Daniel now. So the fraction Daniel does times the time, and it equaled one whole job. That's still the same setup. I'm still doing this. It's just a different piece that I don't know. On the other problems, it was how long it took them to do it together that I didn't know. This time I know that number. It's how long it's going to take Daniel to work is the one that I don't know. So let's walk our way through this. What fraction does Mary do every hour? Well, she does 1/11 of the whole job, right? Every hour. Can we all agree on that? Mary's doing 1/11 of the whole job. I know how long she's working for though. Isn't she working for 4.63 hours? Yeah, so I put a 4.63 there. Now, what fraction is Dan doing, Daniel? 1/x. That's what I don't know. So x, I should put that somewhere. I'll sneak it in right here. X is going to equal the time it takes Daniel, time Daniel work, or time Daniel does it on his own, does it alone. That's what I'm trying to find, right? How long would it take Daniel to work by himself? That's the one I don't know. So I don't know what fraction he does it per hour. But he also works for 4.63 hours because that's what they told us. They're both working for 4.63 hours together. So now I still have an equation and I still only have one variable. I can solve this. I'm going to write it a little nicer because when I do 1/11 times 4.63, isn't that just 4.63 over 11? Right? But that's where that's coming from. So I'm going to write it here because I have no more room. So I'll have 4.63 over 11 plus 4.63 over x equals 1. I'll write it as 1/1 just so everybody matches. Does that make sense where those pieces came from? Do you see that? And now I could have given you this question yesterday. So once you get to this level, now you're like, oh, okay, now it's just a problem. I can forget that it's a word problem for a minute. I just gotta do what I did yesterday. I need to get common denominators, and then I can ignore the denominators and just solve the numerator. What will my common denominator be? 11x. So I gotta sneak in. This one I gotta multiply by x over x. This one by 11 over 11. And my last one needs 11x. But now it's really not so bad. So I get 4.63x plus, let's do what's 4.63 times 11. I don't know. 50.93. And now I have this way easier equation to just solve. Oops. And that is going to round to 8. Did you get 8? So now I know, oh, okay, so if Daniel had been working all by himself, it would have taken him 8 hours to do the whole job on his own. Isn't that something? Let's try one more like this together and then we'll be done. Let's jump to number 13. So you try this one on your own using, it's very similar to the one we just did. So see if you can kind of set yourself up here. I do not know if this one comes out as a nice number. Did anybody get an answer yet? Yeah, is it nice? Yeah. So I have set up my equation here, and I just sort of skipped the step where I write it all out. But JD, I don't know how long it's going to take them, but I know they're going to work for 4.24 hours. So I'm going to have 4.2, well, I'll have 1 over x times 4.24. So essentially, that's just 4.24 over x, right? So there's JD. Now I'm going to add to them Heather. Heather, it does tell me that Heather would have done it in 8 hours if she was working by herself, So I know she's gonna do 1/8 of the job and she's gonna work for 4.24 hours again. So there is my representation of Heather, and together they're gonna do one whole job. Now, once that's written, it's a problem that you did yesterday. My common denominator will be what? 8x. So this one just needs to be multiplied by 8/8. This one just needs x over x. And my last one does need 8x over 8x. Okay, so the equation formed by my numerators, 8 times 4.24 is 33.92 plus 4.24x equals 8x. And now I'm on easy street. We just solve like we've been doing for years. Divide 33.92 by 3.76, and we get, 9.02. So we can round that to 9 reasonably. So JD would have taken 9 hours by themselves. That's it. Congratulations, you have finished Algebra 2. You now know everything you need to know. Oh my gosh. All right, so what do I want you to do for homework? Not much. I'm gonna have you do just 2 problems. How about 5 on the front and 15 on the back? 5 and 15, that's it. Oh, my gosh,
This is our last homework assignment.
this is it,
This is our last homework
the
assignment.
last one.
Wait, can you put the sheet
Wait, really?
up a bit more on
Wait, this is
Read
actually.
down.
the up, so the word from the.
What, you want to see 13?
Yes, please.
There you go.
Wait, so after this, we won't have any more homework.
You won't have any more homework. Because Thursday night will just be study, no homework over the weekend, and then it's just stay for the final. 5 and 15.
It was what? That's the last homework.